Okay, I'm back. It's homework time, alright? It's homework time. Before I do the homework though, look at this. What is this? What is this? Self? AIXI? What? They got there's, what? Alpha 0, Mu 0, what? What is this? What is this? Maximal leg hutter intelligence? What? It converges to AI? What is this? That's crazy. What? Self-predictive? Universal AI? That's weird. That's crazy. That is so crazy. Alright. Alright. Okay. I'm gonna pick a song. Um, or a playlist. I'm gonna pick The Living Tombstone, 01, Me Likey. Let's see if it's too loud. Is this even... Bro, how do I make this be next to this? Like, is it in order of the freaking... the names? Or something? Like, why do these have the freaking... How do I take the audio out of these, dude? Audio mode? How do I just take audio off? Like I wish I could, bruh. I don't really know. I don't really care. Alright. Okay. We're still doing discrete math. Although, we are almost done. This is like the final freaking... This is the final thing, dude. Like, we gotta do all of these questions. Alright, and once we do all these questions, okay, then I'm gonna take a test. And then after the test, I think I'll see what happens after the test. If like how long that takes and whatever. Oh my god. I don't even know if I'll finish this today. I probably should, right? Maybe I'll do a 3-hour homework run. I'm not sure. Whatever. Alright, let's try to do everything here. Okay. So I was reading this. So they're giving me an example problem here. They're saying how many different selections are possible for the donuts. It says they have a large selection of plain chocolate and custard donuts, but they only have 3 jelly and 5 maple donuts left. How many different selections are possible for the dozen? So we're supposed to select 12. I know this is the answer to the problem, but I kind of want to see if I can do it myself. So, yeah. Alright. Okay, so... So we have 5 varieties, right? They say the jelly donuts restriction is that there's only 3 of them. The maple donut restriction is that there's only 5 of them. So, okay. I'm pretty sure, so they're telling us to do the 5 varieties thing. So I'm thinking, I'm gonna use like this thing because that is the code words thingy. We have multiple varieties and you want to select a number of them. So what if I do... Okay, I'm back. So Alright, let me see if I can do this on Notepad++, so you guys can see what I'm talking about. Alright, so there's 5 varieties, 12 donuts. So there's 12 zeros, 4 ones. That is all our code word thingy. So apparently, the restriction, okay. The restriction is that there's only 3 jelly, and then 5 maple. Okay. What the skibbity? I don't think I know how to do this. Like at a first glance, I don't know. This seems kind of complicated. Like I don't know how to approach this. I'm pretty sure I could do. I'm pretty sure I could do. What's it called? The freaking complement. But I refused to learn complement in the previous videos, so I don't know how to use it. I probably should have learned how to use it. Anyways, let's see. We could. I think I know how to use it. Right. So what? Okay. So we're selecting 12 donuts. Right. That's what we're doing. Let's call that U to mean all of them. And that would be, let's say it's the choose, right? 12 choose 4. Okay. That is the total number of donuts. Like if there was no restriction on the jelly and maple donuts, then it would be that. We have a restriction for the jelly. Let's say jelly at most 3. Right? So jelly at most 3. So what? How do I do that? Oh my god. So the cases, how I used to do it is I just count how many different selections you have based off how many like jelly donuts you picked, and then yeah, so like I would choose 0. So this means, let's do this right. Select 0 jelly. I'm gonna call it, so we got 0 jelly plus 1 jelly plus 2 jelly plus 3 jelly. That's what this means. At most 3. It means you can pick 0 to 3 jelly donuts. Right? And what is this equal to? What is that equal to? Select jelly at most 3. Okay, so if I did this, right? So the 0 jelly, if you picked 0 jellies, donuts, well, yo, this is kind of weird. This is kind of weird. Wait, so 3 jelly donuts, 5 maple donuts? Huh. Okay, this is where complement comes in, right? Because you can select 12 donuts. Let's say you selected 4 jelly donuts. That would be the inverse, right? thing, complement. Alright, let's do that. So this would be select 4 jelly donuts? Is that what that means? Select at least 4 jelly donuts. Right? That's what that means. Select at least 4 jelly donuts. Okay. My chair doesn't go down anymore. Whatever. Alright. And this would mean you would select 4. Okay. I can do this. I can do it. Also, this equals u minus negative a inverse. I'll put a different symbol so it's not minus. Okay. Select at least 4 jelly donuts. This would be equal to selecting 4 and then allowing you to select more donuts. So if you did that, if we selected 4 like jelly donuts, you would have 12 minus 4 donuts left, zeros. So we would have 8 zeros, 8 zeros and 3 ones, right? That would be 8 choose 3. So that's that. Alright. Okay. Very nice. Okay. So we have A in total, which is U minus complement A in complements. Okay, and alright. Let's make B equals select the other one that they said. So 5 maple. So maple at most 5. And this is the same thing pretty much as the last one, except we put maple and 5 for that. This is pretty much the same as these two. So I'm just gonna say this is equal to this, and then we're gonna define the complement, which is select at least 6 maple, right? And then doing that means you select 6 of them and then you'll let the rest happen. So it's very similar. Do 12 minus 6 is 6, of course. So we have 6 zeros and 3 ones. Right, choose 6, choose 3. Okay, now that we have that, we can do this. U is this minus B complement. Right. Okay. So now that we did that, they are asking how many different selections are possible for the dozen donuts. So the bakery only has 3 jelly, and also they have a large selection of all the other ones. So there is no restriction other than these 2, A and B. So what I'm looking for is... What am I looking for? Selecting all of them? Or something? Or like doing this and this, I guess. Alright, whatever. So let's get the intersection thing. So let's say A and B intersection. So if we did the intersection, What would we actually like pick for this? 12 zeros. Alright, let's put some ones in there. So we have 5 categories, 1, 2, 3, 4, 5. And if we do A and B, that means we select jelly at most 3. And also select maple at most 5. But I don't really know how to do that, so I want to work with the complement. So that's not actually what happens. Let's put this as comment. So this one is U minus not A and B. Right? So let's figure that out. Okay, so this is gonna be, so A not in B equals not, what is it, not A or not B, right? Isn't that how it works? De Morgan's law or whatever. I'm pretty sure that's how it works, right? You go like this and it flip. Okay. See, it's right here, the answer. Very nice. Okay, so what's this equal to? Okay, so this one is not A, which is this. And then we just add it here, I suppose. I suppose we add it. Right? We use or as adding. This is intersection. Okay. This is kind of weird. This is kind of weird. Because when you do the intersection, I don't know. Is this correct? Aren't we like supposed to subtract the motherfucking the intersection of not A and not B? But that's what we're like trying to figure out almost. So we're trying to find the intersection of these two as also 4 jelly donuts and 6 maple donuts. They have intersection. Yeah, right? I gotta figure out here what's going on. Okay. Nah. I gotta figure that out. Because when you do this, okay, let's see. So yeah, I would do the intersection. So I'd say this plus this minus this right there. So I do have to figure this one out because I have this, but I do not have this one. So I'm gonna figure that one out, I guess. So it's this one and this one, right? Select at least 4 jelly, and also select 6. So we just select both of these at the same time, right? Is that how that works? I think that's how that works. That kind of makes sense. Okay, I'm gonna move this here because more space or whatever. So Okay. And right there. So we're selecting at least 4 jelly and at least 6 maple. So we're gonna count how many. So we have 2 zeros left, because we selected 10 in total to start with. And we also still have 3 ones. So what? Isn't that kind of weird? Wait, 2 choose, that's 0, right? Oh, I've been doing this wrong. I've been doing this wrong. Uh-oh. Uh-oh. No, look guys, look. It's 5 choose 3. 5. Because he's supposed to add these up. Alright. Okay. 5 total. You put in the total. Alright, that's Jesus. Alright, I gotta fill these in. I gotta fill these in, bro. I'm gonna erase all these. I'm gonna update these with the correct answer. Alright. So we have 12 zeros, 4 ones, 16 total. There you go. Alright. You can do 16 choose 4 or 16 choose 12. Alright. Right, 16. Yes, of course, you could do the same thing. Alright. So this one so I got this minus this here. This is 11 total. Right, so let's put that there. Let's fill in everything with the correct answers. Alright, so we got that. Alright. What is 9 choose 3? Is this, which goes here. Right, and then this one. There you go, 5 choose 3. Perfect. Perfect. Perfect, okay. So let's fill these things in, shall we? So we got this minus, so this is u minus the complement of that, and then the complement is gonna be here. So we get the thing A plus B complement B minus this thing here. Perfect. Look at that, guys. Boom, that goes here. Alright, so this is our final answer, I guess. So A and B is this. That was kind of... I've never done a problem like that before. Like this many restrictions and stuff. I have no clue if this is correct. So... yeah, I'm gonna put this down here to represent our final answer. Now I'm gonna type it out. Alright, so we got 16, choose 4, minus 11, minus 11, choose 3. Wait, is this correct? I want to make sure I didn't like make this crazy. Okay, so this is, wait, let me know that. I don't think I did that right. So let's redo that. So this is minus this whole thing. So this goes in here. Yes, of course. Of course. Okay. So we do minus this, minus this, plus this. Okay, now that's better. Jeez, I almost let that happen, huh? Let that happen. Alright. Alright, let's retype it, cause alright. 11 choose 3, 9, choose 3, 5, choose 3. Alright, apparently, this is what I got. Alright, let's see if I got that correctly typed in. So plus 5, choose 3, negative 9, choose 3, negative 11, choose 3, and positive 16, choose 4. Okay. Okay. Okay, so this is my final answer. That is not this answer. 11:30. We got pretty close. Pretty dang close. Let's see what is happening here. What did we not do? We probably typed one thing incorrectly. Not gonna lie. What? Alright. What did we not do? I want to see what we did differently, cause yeah. So I put 3s here, and they put 4s on the bottom. So was that the right call? I think it is supposed to be 4 1s. Right? Like, cause it comes from here. I put 3 1s. I think it's supposed to be 4. Because we can still choose more jelly donuts. So we're not done choosing them. So we still like include the 4. Yeah. Oh my goodness. Alright, let's redo this. Here, let's take out these. Okay, so I think it's just those. And this one as well. So that right there, we can't do that. This right here. Okay, so move that up a little. Yeah, so we would have 4 1s, 12 total, because we are still selecting more jelly donuts, so we're not consuming the 1 for that category. So yeah, so now it's 12, choose 4. That is this right there. That's A. This one, right, is also still 4 1s because we are not consuming all the maple donuts. We still choose more of them, so we don't consume that extra 1. So there's 10, choose 4, right? Okay, and then we get into here, which I'm pretty sure is also just 4 as well, because we say at least for these here. So yeah, that makes sense. Let's put 4 there. Why not? Okay. Yeah. So let's put these numbers. So we got this. It's this. Oops. Minus this, which is just that. Right. And this right here. Okay, it's this whole thing. We put that in there. Okay, now we do that. So we do this. Okay, so there we go. I think this is better. Alright, so I have to know this next time. Next time I do a problem like this, I have to remember to do that. Alright, so 16 choose 4 minus 12 choose 4 minus 10 choose 4 plus 6 choose 4. Oh yeah, 1130. That is the answer. Alright, perfect. So I know how to do this. I guess I know how to do it. I just need to be very careful with the this stuff, subtracting the intersection and remembering to do this correctly, the code words. I was a little rusty on that. Now I think I got it. And let's just get this check mark. Right, so we did that. Very nice. Here's another thing. Jesus, what is this, man? Alright, we could probably do this. Alright, we could probably do. We did the previous one, so we can probably do this. Right, so okay, so let's just paste that in there. Paste 2 Q's. Alright, so the license plate number consists of 7 characters that are either digits or capital letters. Okay. Okay. Okay, so all of them, let's just say right now, all license plate with no restrictions is 7 characters, which is 10 digits plus 26 letters to that. Okay, so this is to the 7th power, which I don't really want to put that number yet. Anyways, it says a witness of a crime briefly sees a license plate of the getaway car. The witness remembers that the license plate number starts with a digit and has at least 2 Q's. Okay. Okay, so A equals starts with digit. B equals at least 2 Q's. Right? So let's say it equals U minus the complement. Alright, same with this one because actually I don't know about this one. I'll probably be able to do that one without complement. But this one I'm going to do complement because it says at least. Wait, actually? Nah. Nah, because at least you don't need complement to easily do that one. Let's just do starts with digit. These look simple enough. So starts with a digit is gonna be, so there's 7 characters, right? The first one is guaranteed to be a digit. There's 10 digits, so there you go. It's gonna be this times that. Pretty sure. Yeah. And I don't think we have to do all that, but so it starts with a digit. It's easy as this. There's 10 digits for the first option, and for the other 6 options, you can put a digit, anything. You can just put anything. So that's digit or a letter, and there's 6 of them. So there you go. 10 digits, 26 letters. There you go. That's A. Here they say at least 2 Q's. So for that one, I can probably like do the code word thing. Right, I'm gonna do the code word thing because well, actually, nah, I'm not gonna do that. At least 2 Q's. Here's what I think it is. The first queue has 7 choose one places to go. The second queue has 6 choose one places to go. And now there's 5 characters left. So you just do this. Right? Huh? Is that what you gotta do? This looks pretty good, right? At least 2 queues. We are selecting 2 queues to start with. The first one has 7 places to go. The first one has 7 places to go. The second one has 6 places to go. And the rest of the characters, there's this many possibilities for that to happen. So yeah, that's that. We are looking for the intersection, right? It has, remember, it has both of them. Both of these conditions are true. So this is the intersection, I guess. Okay. So yeah, what is the intersection? I don't know. I don't know what the intersection is. Is this where I would use the complement? I think I might want to use the complement because I don't want to. I don't know, bro. Because what is it? Oh, I get it. No, this is easy. This is easy. It starts with a digit, right? 10. It has 2 queues. So let's get those queues in there. The first queue has 6 places to go. There's one of them. And the second queue has 5 places to go. Choose one of them. And for the rest of the numbers, it's just that. Right? I don't know why I calculated these, I guess. Is that how that works? I didn't even need to use U. What is this? So we chose, it starts with a digit, so 10. And then you choose 2 queues. And then you choose the rest of the numbers, the characters. Alright, let's just calculate that, see what we get. So 10, 6 choose 1, times 5 choose 1 times 10 plus 26 to the 4th thingy. We get a number, pretty large number. They got a different number. So okay, they got a different number. What are they doing? What did they do? Apply the principle of counting by complement. So why do they actually use like the complement? I got a different number. Mine starts with 5 and it has many more digits than what they got. Come on, what? A and B is... Okay, so the license plate starts with a digit and it has at least 2 queues. At least 2 queues. Starts with a digit. 6 more places for it to go. What is that, by the way? 6 choose 1? Let's see. 6. And 5 choose 1 is just 5. Okay, what? Is this... So what is too big here? Is it this thing? 10 plus 26 to the 4th? think that is pretty large actually. Because, wait. 1, 2, 3, 1, 2, 3. I don't know, it's just, I don't know. We're doing something here not correct. What do they want? So the license plate starts with a digit. And has at least 2 Qs. I mean, I just calculated it precisely. Like, what? Okay, what about, okay. What if I do something else? Okay. What if I do U, A or B? Alright, let's try that out. Let's see what we end up with. So A or B could be the negative this thing, this thing, and that is equal to U minus this whole thing. Alright, U minus that. And so we have to find these out. So what is this? The opposite of A is it starts with a digit, and the opposite is that it does not start with a digit, so it starts with a letter. Alright, isn't that what that is? Starts with letter. What? Okay. So there's 26 letters. And then the rest of the options is just that, right? 7. Isn't that what that means? Alright, I don't know, but I'm gonna continue and I'm gonna see if I get a weirder answer or something, the same answer or what. So, wait, so this and this. I have to find their intersection. I'm supposed to find their intersection. So this is at least 2 Qs. At most 1 Q is the opposite, right? Because at least 2, and then right there. So this would be 0 Qs or 1 Q. That's what that is. So, what is that? What is that? What is this? So if we pick 0 Qs, do these have any intersection, by the way? Because if you do OR, you have to subtract the intersection, and I don't even know if this has an intersection. These probably have an intersection, right? Let's see. They must not have an intersection, right? Because none of these could be the same. Because if you have 0 Qs in this set of strings, and in this set of strings you have 1 Q somewhere, then they're bound to be different because they just don't have the same number of Qs. So okay, so there's no intersection with these, so I think I can just add them. So yeah, if there was 0 Qs, we would just have 10 plus 25 for the 7. Alright, because instead of 26 letters, there's going to be 25 because you don't choose the Q. Everything else stays the same. Right, so if you choose 1 Q, You're choosing one Q. That would go somewhere, right? So I think that's 7 choose 1 times the rest of the thingies. So what? Yeah. So 10 plus 26. No, 10 plus 25 to the 6. 10 plus 25, because you're using 1 Q. You used up all the Qs, so there's 25 letters now. And you already chose one of the letters, the characters, so now you only have 6 of them left. And this is choosing where the first Q goes. So yeah. Okay. I'm going to calculate this, I guess. On my calculator, see what I get. So yeah, 10 plus 26 to the 7 is U minus this. Hold the phone. What? I didn't even figure this out yet. I did not figure this out yet. Okay, so not A and not B. So their intersection. Bro. Alright, what's the intersection? Do I even need to find this intersection? Can we just do this or something? Or like on the inside we do something else? Not A and not B. Can I do... This is U minus A. And this is... Bro, but I have to do the AND. Oh my goodness. A and B. Alright, what if I do a different calculation real quick? I'm gonna keep this here for safekeeping. But this one I'm gonna try to change it. So the first thing is this. Okay, but this doesn't make sense. Can I find like the inverse of this? Can I do something about that? Can I do the U minus? Can I do this right here? Can I do that? I think that's right. Yeah, that's right there. So yeah, I'm stuck. I need to find their intersection. Right? Because if I do this or this, I need to subtract their intersection. Let's write that down. Right, so we got this plus this minus A and B, but let's put that in parentheses so we don't get confused there. We have to subtract. We have to find this term here, which is right here again. All right. So what is the intersection? What is the intersection? Can we use U and these to find it? Or do we have to like do something else? Because I did this, A and B. I thought that was the correct thing to do. But I don't think so. Oh my god. Alright, let's see what they... Let me reverse what they did and see if I can like figure out what they did. So they did so D means it starts with a digit. What? E means it starts with a digit for them. So, okay. They put that their solution is equal to this. That's what they put. Right. They... D... What? What about the two Q's? Oh, they put that here. So, starts with a digit and has a number of Q's. Oh. I mean, what? That's kind of easier. So, I'm supposed to find the intercept. I mean, I still don't get why this wasn't right. Start with a digit. At least 2 Q's. You got 10 digits right in the beginning. You choose 6, choose 1, which is here. Which is right here as well. 35 to the 5th. We got some stuff in here that makes sense. But here they're subtracting some things instead of multiplying everything. Gosh darn it. Okay. Okay. Is there a 5 in their answer? Did they do that? Maybe. I don't know. I put a 5. Nah, this can't be right. This can't be right. Oh my god. Starts with a digit. Choose where the Q. Oh, I think I can't do this because they have an intersection. So I can't, so I have to literally find this right here. Damn, that's, yeah. Oh, right, I think I get it now. I think I get it. We can't just blindly do that stuff because, yeah, it has an intersection. This has an intersection. Yeah. Because if you choose 2 Q's, or wait, what? Yeah, right, look, because if you choose 2 Q's, if you choose 1 Q, or, hold up. So this is wrong, right here. This one, that's not right. So this was, the complement was correct to do on this one. Makes sense. So this somehow makes sense. Okay, because I got A and B. The intersection. And that was hard to figure out. So I broke it down to this. And if I kept expanding it until I have this, which is kind of confusing. This one was easy. Starts with a letter. That's pretty easy. This one I need to find the intersection. So I literally have to find this term here. Like I said. Okay. Why don't I listen to myself? Alright, so... Alright, let's start trying this. Okay, so not A and not B equals... Start to the letter and this. What the hell? Wait. So, can I put parentheses on like that? No. Whatever. Start to the letter and this. So, how do I calculate that? The intersection of this? So there's two possibilities. It starts with the letter in this, or it starts with the letter in this. Dude, that's what they did already. They literally did that here. It starts with the digit and has the zeros, starts with digit and has the 1Q. 0 Q's and 1Q. Bruh. Alright, whatever. Let's continue this. So yeah. So let's do that. So this is another law. Right. So we have starts. This is the more, I don't know what this law is called. So this is and 0 Q's, or starts with letter and 1Q. So this is the expansion of this thing. You like distribute. It's kind of weird, but I don't really care. It's a logic thingy. So let's find this term. Starts with the letter and 0 Q's. So it starts with the letter. That's 26 thingies, and then for the rest of them, it has 0 Q's. So that just means 10 plus 25 to the 6. There's an or, so we put a plus. This is the same thing, except we have 1 Q. So start with the letter. It has 1 Q. Right, wait, it has 1 Q. What is that again? What is this? 1Q? I'm having a brain fart. I think it's that. Yeah. Okay, that makes sense. And in here, we're gonna put this thing right there. Okay. This is kind of weird looking. So it starts with the letter. 0 Q's. So the rest of them, 25. Okay, and then start to the letter and 1 Q. That's 1 Q because there's 6 places for the Q to go, and then we select 5 other characters, which could be this many possibilities per character, and there's that. Okay. Kinda crazy answer right here, but they got a much simpler answer, I'm not gonna lie. But I guess our answer is technically correct. This is a big bad answer. Oh my god, look at this. No. Guys, I don't like this. Bro, how can we simplify this? Okay, for one, maybe we should try this out. Alright, this is... There you go. A little more simplified. No, not as many parentheses. This, though... let's break it down a little. This is 36, 35, right? Yeah. 35, 35, 35. This is 6. And yeah, this is 7. Okay. It's a little bit simpler now. This is 36. Okay. So it's a little more simpler now. There's still a lot of parentheses. Let's take out some... I think we need parentheses on this one, right? Let's just keep it, whatever. Alright, so there's the U. Let's do the A complement. B complement is this entire thing. So let's not make sure to propagate. Let's make sure to propagate that. Okay, and then this thing is adding. So yeah. Okay, it's still pretty big, but I don't know. Easier type, I guess. Okay, so the 36 to the 7th minus 26 times 36 to the 6th minus 35 to the 7th minus 7 times 35 to the 6th plus 35 to the 7th. Hey, these cancel. This one and that one. Look at that. I'm gonna keep it just because I've already typed it all. Alright, so plus 7, whatever. Jesus, that's a big number. Something went wrong. What happened here? 7 times... Oh my goodness, what is this? Alright, let's actually try this out. So 35 to the 7. Alright, we have that there. These the 35 to the 6. Right, let's 20. Alright, so we got 7 minus 26. This is 19. Take that out. Here we got wait, what did I just do? Wait, these two are the same. So these cancel, right? Right. Alright, these cancel. 35 to this. Yeah. So literally turns into this. Apparently. That's kind of odd. That's even different. I simplified it wrong. I simplified it wrong. Oh my goodness. What the heck? So what did they get? Remember they got a... Okay. They didn't even have to the 7th. They didn't even have this. Where did I go wrong? This or this is this plus that minus the... Oh my goodness, what? So 36 to the... Did they even use that? 36 to the 7? I don't even think they did. Maybe it was supposed to cancel out at some point. Is that right? Starts with the letter. These are just... Oh, this must be 6. No, it's not 6. It's literally 7. Okay. What? Starts with the letter. Did I do this right? Alright, so this is A and B. Starts with digit and has at least 2 Q's. Right. You get all of them minus the complement. let's even make this easier on us. Let's make this even easier. Let's just put that there just to see if that goes correctly. So u minus the complement grid. The complement is equal to this, not A or not B. Yes. Not A plus not B minus their intersection. Alright. And then you propagate the negative. This is the intersection. So you do u minus A minus B plus this. What? Okay. I probably should have kept the entire digit thing. So whatever. So complement A is this. So it starts with a letter. Right? Starts with a letter. So it starts with a digit. And if it doesn't start the digit, it has to start with the letter. That makes sense. I hope this one is right. Funnily enough, could be wrong. So the first one is a letter, 26. You have 36 options. There's 6 of them. Characters left out of 7. Okay, and then this one I said there was no intersection. Which did I do this right? Because yeah, they're disjoints. They're disjoints. So this is good, I think. So if you have 0 Q's, you subtract 1 from the amount of possibilities, and then there's 7 characters, right? And the other one is there's 7 places for the Q to go. The first one. And then there's 6 characters left. You chose one of them, and then you're not choosing the Q, so you put 35. This is probably right. So we got this and this, so let's put those in there. Right, this. Maybe I typed that one wrong, but I'm gonna put this in parentheses. 35 to the 7. Huh, I canceled that somewhere, didn't I? I probably needed that. Alright, whatever. Okay, and then we are adding this whole thing. Let's see if we did this right. So it starts, so not A, not B means this. So it starts with letter and this, yeah. And then the logic expansion thing of that is starts with letter and this, or starts with letter and that. Okay, and so let's check. So starts with letter and 0 Q's, so starts with letter and then the rest doesn't have a Q. 35, 6. Starts with letter and there's 6 places for the Q to go, and there's 5 characters left, 35 options. Yeah, let's add that up. Alright. Let's paste these. So this term gets negative. Alright, so let's do that. Negative. And this just gets added. So let's try to simplify some things. So so the so the so 35 to the 6 we have some of those. So we got this one. We got these two. Alright. So -7 and 26 is 19. Positive 19. Okay. So let's take that. And it seems like everything else is kind of different. 35 to the 5th. We don't have that. 35 to the 6th. We don't have that. 35 to the 7. 36 to the 6. We don't have. So this is our thing here. So let's try this one out. Let's try that. So minus 26 times 36 to the 6. Minus 35 to the 7th. Plus 19 times that. Plus 26 times 6 times 35 to the 5th. I did not get that. God damn it. What the heck? They don't even have it to the 7th. They don't even have it. But I was doing it differently. Did I type it right? Okay. Yeah, so plus. Let me go to the beginning. So we got 36 to the 7th. Minus 26 times 36 to the 6th. Minus 35 to the 7th. Plus 19 times 35 to the 6th. Plus 26 times 6. Times 35 to the 5th. Damn, that's still the same thing. Okay, what if I plug this into Wolfram Alpha? See what I get. The same thing. Alrighty. What? Okay, something is wrong here. Something is just wrong. Maybe it's this. Maybe this is wrong. Alright, let's search up. Let's search up the Boolean algebra laws, because maybe I just did not do that right. So the one I'm looking for is probably in this one, distributive. Alright, distributive. So no, I don't want the. Okay, no, that's good. Okay. What is it, distributive or associative or something? So I have a thing and then or. So it's so they're different. So it's gonna be this one, this and this, or this and that. This and this, or this and that. I mean I did that correctly. What? They don't have an intersection as well. Like this is the or. So when you do or, you're supposed to subtract the intersection. But wait, it starts with letter. Oh my god. What is the intersection? Starts with a letter, which these two both have. But this condition, they have different numbers of Q's, so they can never have the same string, so this would just be 0, and then you just wouldn't even type it. So I don't know, I just have this. Is this correct? So it starts with the letter. Is that correct? Is this a correct thing to say? Because like if it starts with a digit, you know, what is the complement of starts with digit? I thought it was starts with letter, but maybe it's not that. Apparently, physics starts with letter. This is U and B. Maybe I don't need the complement. Maybe I don't have to include this at all. Maybe I don't have to do that. Maybe I can directly calculate the intersection and did not have to do all this to get this term. And yeah, okay. So what is the other one? So starts with digit and has at least 2 Q's. Right. Starts with a digit, and what did I even do wrong here? Okay, here's another thing. So apparently this is something's wrong here. Something's wrong because I followed logical laws here, I think, correctly. This is U minus the complement. You can do that. Alright, and then the complement, you distribute the negation, and then you flip the thing. There's De Morgan's laws right here. Right. So you flip it, do the negations, and we can calculate this directly. We expand it out. We add these here, and then we subtract the intersection, and then the intersection, I apparently got this number, and that was not correct. Maybe. But oh my god. Okay, I'm gonna just check again if I did this right. Okay, I have a better idea. What if I directly just paste in all this stuff? Like I go here, right, and I just literally replace everything with whatever I got for those, and then I plug it into Wolfram Alpha, right, and then it'll let me know if it'll give me an answer. No, I got the same thing. Oh my goodness gracious. Let's bring this over. We are going to need you, Wolfram Alpha. This is like orders of magnitudes off, and I'm suspecting it's this freaking that thing. Maybe this has to be larger. Maybe this has to be to the 7th for some reason. I don't know. That can't be right. Okay, so apparently this is not right. This is just not right. So something here is wrong. Maybe this is not supposed to be the final answer, although it literally is. I mean, starts with a digit, at least 2 Q's. The dude said right here, it starts with a digit and has at least 2 Q's. How much more direct can that get? Starts with a digit, at least 2 Q's, and both of them. Alright. I don't know how to calculate that directly, so I do U minus the complement. Alright, which is... maybe this is wrong. I have no clue. 36 to the 7th is U. Okay. Oh, I think this is wrong. How could I have been so silly? Guys, this is wrong. At least, oh my god. Guys, this is not the complement. This is the freaking, this is B. This is not the complement. Oh my god. Alright. Let's, wow, that's embarrassing. Oh my god. Okay. Alright, let's, fix that up a little bit. I felt like, oh my god, that, Jesus, bro, I couldn't just figure that one out. Okay. Yeah. So this is correct still. So what I'm gonna do is, I'm still gonna keep negative B in there, but I'm gonna define it differently based off of what B is, because this is B. This is not a B complement. Oh my god. Jesus. Okay, so B thingy is U plus this, right? Or something like that. What is it? It's B equal. Wait, let's read that. So we got B equals U minus that. Okay, so B plus U equals negative that. So negative B minus U equals the complement. Alright, let's do that. Okay, so we don't... Let's just see that. Alright, so this is negative B. Actually, that's negative B. So this is negative B. That's where the U comes in. This is where you cancel it out. Oh my god, of course. Of course it starts freaking working, bruh. Alright, so let's paste this here. Let's just paste that in there. Well, let's put parentheses around it and then put that so we can plus B. Wait a minute. Minus negative U. That makes U even larger because it's like plus U now. So it would be 2U. Hold. Oh my god, no. That, I mean, that could be right. You know, that could be right. So we do plus. Did I freaking do this right? No, I'm pretty sure I did this wrong. I'm pretty sure I did this wrong. This has to be wrong. I'm not gonna freaking let myself. Alright, so B equals this. Alright, manipulate the goddamn variables. Alright, let's do B minus U equals negative B plus U. There, this is the freaking. So silly. So silly. I'm on a roll today, bro. This is not it. Alright. So, okay, let's So we got this. This turns into positive b. The negative distributes to the u. And the u's cancel. Finally. Look at this. This is a lot simpler. Alright, there's no u's. Oh my goodness. Alright. Alright. So now here we go. Okay. Now here we go. Took a little while. Alright, it took a little while for me to figure that one out. But yeah. So now we're just adding everything apparently. So that's cool. Alright, let's let Wolfram Alpha. No! It's still wrong! It is still wrong. What did I do? Guys, I think I need a break from this. This problem is freaking destroying me, dude. Oh my word. Did I propagate this properly? Negative A. Negative A. Negative complement. The complement right there. Jesus. Alright, and this is negative complement. No. Alright, let's put this properly in there. Okay. Okay, okay. Alright. This is that's that, right? That has to be that. Did I do that? Because plus negative b plus u. And what the heck? Okay, that gets, yeah. Okay. And this whole thing is negative. Okay. So let's type that out. I hope I please do this correctly myself. Alright, I inverted everything. Alright. The u's have to cancel, bro. Because there's a positive u and there's a negative u. And they cancel. Alright, they literally cancel. Alright, so we got this. Right? We got a positive b. Right? We get a positive this thing. Right? There's just three terms. Just three terms. Right? So what we do. Okay, so it starts with letter. Right? Starts with letter. You know what? You know what? I have an even better idea. Okay. I'm not even gonna do this. Because this might be wrong. You know what? This just might be wrong. This literally might just be wrong. So I'm gonna do this. Alright. I'm gonna do that. And I'm gonna try to, you know, piece this thing together. Alright, we subtract that to get that. Alright, let's do that. Okay, you know, we multiply it by -1. Right, and then we propagate the negatives. Right, and then this is what we get. This is what we get. So the complement of A is this. So that's the complement of A. So why don't we type that in there? Why don't we type that? Okay. Let's duplicate this and let's get the complement of A. Alright. Because I don't trust my definitions. So we got, uh-oh, this is negative u. I don't know if that's, That might be too large. It might turn negative, but I don't even know, bruh. I don't even know. So this turns into a plus, turns to minus, propagate the negative. Okay, we got this. And now we just let that happen. So this is A. That's A. Alright. Positive A. Minus big number. Kind of concerned about that one. This is plus B. And then we're adding the not this one. And then we're adding this to Mr. Alpha here. And it's even different. It's what? Wait, is it different? No, I think it's... No, it's the same. So, what? Something's wrong, guys. Something is wrong with my calculation. Even using just the A's, like not even the comp. This could be wrong. This could be wrong. Are we supposed to... Something happened to be like too large. What if I just take this out? What if I just take that out too? Take that out too, why not? Let's take that out too, why not? Okay, that's not gonna... Oh, this one. Guys, what the heck? What did they get? Oh my god. They only got 3 terms. And there's a 10 for their terms, and then a 6 right here. Which kind of makes sense. There's no 7th. Nothing to the 7th. Like, bro. Bro. Oh my god. There has to be something totally wrong with it. How long have I been working on this problem, dude? I've been working on the same problem for like too freaking long, dude. Jeez Louise. I'm gonna have to come back to this because I don't even know. I don't even know what happened there. Oh my god, dude. Ooh. Jesus, bro. Oh my goodness. Alright, let's, I'm just gonna erase that. Erase that too. We will come back to it. Okay. Is this, oh my god. Alright. We're gonna come back to it. So, yeah. So a manager of a grocery store purchases 50 crates of soda to stock the store. I've seen a problem like this similar where they talk about this soda and whatever in 50 crates. But yeah. So yeah, there's 5 varieties of soda. Okay. How many ways can the manager purchase 50 crates without ordering more than 25 of any particular variety? Uh-oh. Without ordering more. So at most 25 is what they're saying. Oh lordy. And there's 5 varieties. So yeah. Yeah, okay. I'm gonna have to find an easy way to word this because this restriction is kind of sussy, kind of suspicious. Okay, so they're saying the following series of questions leads to the final answer. So I'm gonna do these, I guess. So how many ways are there for the manager to purchase soda if there are no restrictions? on the number of each variety the manager chooses. This is a code word thingy. It's gonna be 54. Choose 4, I guess, because yeah, a code word thing. We have 54 numbers, 50 zeros, and 4 ones. 50 zeros represents where the crates are. The ones is to split the zeros into their categories. There's gonna be 4 of them. Cause 5 minus 1, whatever, I don't know. It was a previous lesson. Yeah, okay, so this one is the number of ways that the manager can purchase 50 crates. What? Oh! Ooh. What? How? What? I thought it would be this one. Okay. This is that. That's what freaks me out, bro. So the number of ways that the manager can purchase 50 crates of soda with at most 25 from any variety. What? So the opposite of that, not a compliment, is at least 25 from a variety. Alright, wait, at least 26. Yeah. Yeah. Okay. That makes kind of sense right there. I guess I need to use compliment. So you would just compliment the freaking whole entire restriction and then like see what that happens to be. This is what I did not want to freaking find the union of a bajillion things. Hell nah. Hell nah. Hell nah. Okay, so it says this be the set of ways to choose from the ith variety was the correct expression for x from the previous problem. What? I did not know to do that. I didn't know to do that. Anyways, it says the x is the number of ways to purchase soda with at least 26 of some variety. That is the union. Because if you intersected, that would mean all of them have at least 26. Union means at least one of them has it. So what? So V1 is picking at least 26 from the first variety. So, alright. So originally there was 54 zeros. We are choosing 26, taking away. So we're gonna have 28. Choose the, and we got 4. So yeah. What is the intersection? Don't know. I don't know what the intersection is. I think it. Wait, is it 28? Wait. So if you choose 26 plus 26, isn't that more than freaking 50? So that's 0. You can't even. Yeah, you can't choose more than 50. So it says, what is this? 5 times this, because they don't have any intersections and each of them is the same thing. 28 choose 4. Okay, so how many it would be? So this is the whole thing minus this. Right. Okay, that was pretty. That wasn't too bad. But they did give me all the steps. So I have to do the steps myself. That's what I have trouble with, dude. Sometimes I don't know how to do that. Um, yeah. I mean, they gave me 7 steps. So what did they do? They started with everything without the restriction. And then they said, do the complement. And then they said, what is the complement description? And then I said, I got this wrong initially. And then I said, why is it wrong? And then I looked at it and I was like, huh. At least. So it's going to be at most 25. It's going to be then at least. And then like 1 greater. And then if it's from any of them, like, not of any is some. I guess. So that's what that is. And then the implementation of that, I don't know what that would be, honestly. No, they split it up because they said the union of all of them. How did they know to do that? The union? Okay. How did they know to put it like this? The number of ways to purchase soda. With at least 26 of some variety. So I would just say 26 from each individual variety at a minimum, because it says at least. Okay, I guess so. And then I found the first one, which is what I said it would be, which was this, because apparently I figured out how to do that because of the at least of some variety. Okay, and then I said, what is the first one? Oh my god, dude, what? Okay. 50 crates. This is like a goddamn program, dude. They give me the steps. Oh my god. I gotta memorize this program, dude. Okay. So the set of ways to choose that. Okay. Variety. I'm having a. Oh my god. Dude, I don't want to do this. I really don't want to do this. Gotta do it though. Gotta do it. Number of ways to choose it. I'm gonna drink some water. I gotta do something different. My brain is fighting back. My brain is literally fighting me back. It's like, don't do the homework, David. Brother, you gotta do the homework, or else no degree. Or else no degree. Oh my god, okay. So this is the number of ways to choose. You know what? I'm gonna call it right here. Alright. I'm gonna call it. I don't think I need to do these. I'm just not gonna do them. I'm not gonna freaking do them. Because I did every other lesson in this. I did almost. I think I don't even know, bro. I don't care at this point. I did most of them. I think I can. I think I'm good with counting. So I'm just gonna continue forward and do probability because this is what I kind of don't totally understand. So I'm gonna need to do. This is the first. Oh my god, dude. This is the one that I didn't get how to do. All right. I'm going to statistics now. So let me give myself a little break time here. Um, yeah, I'm gonna do goddamn 15 minutes. All right, 15. Okay, let's just play this, guys. Jesus. So what is this? Arms race squads. Let's go to this squad. Let's see what. Maybe that's the thing. That's not squads. That's clan. All right. All right. I have an idea. Also. There's like a website that I think it's this or something like Sandbox R7. This Sandboxels, yeah, 7, yeah, this website. I think they have this. I like this website, bro. All right, so we got this. All right, I'm gonna go to this one. Longest characters. Can I get a tall thing? Here's what I'm gonna do. I'm gonna put one of those. One of the. Oh, it's not gonna let me. Oh man, come on. Come on. Let me put the thing. Alright, how about this one? Let's try that one. Let's try the big line. It's not letting me. What if I inspect element, right? And I force it to have the thing. So can I do that? Can I force it to have a certain thingy here? I don't know. Why is it rejecting my text? Can I? Yeah, I don't really. Oh my god. Whatever. I'll put the freaking A. How about that? Get an A. No, I chose the wrong game mode. No. Alright, let's go here. Let's see if my name pops up. Alright, so I'm gonna do that. Let's get our name. This dude said remove growth. What? Growth is a cool game mode. It's a cool game mode. Alright, let's see what Betion, whatever that character's name is. Alright, let's do crack shot. Okay. Let's try to kill these people. They're gonna try to get me. Let's see. Let's fight back a little for the sake of our team. Alright. Didn't work, but it was worth a try. Alright, let's see. Can you guys see this, by the way? Like, how well can you see this? Pretty well. Alrighty, let's do this again. This is super duper laggy. My god, alright, please, either, can I get some hits on these people. Teammate go, teammate go. Oh, oh, there I go. Oh, look at that. Oh, I feel bad now because my team. I left my teammate, but you know, it's for. Oh, I'm back. I'm back. Please don't die, teammate. Teammate, don't die. There. Oh, I almost got back in time. God dang it. Okay. Alright, let's start planning. What is a good build for this map? What is a good build for this map? So maybe this one, I guess. This one. Alright, there's a giant tank thing here. Trying to get us. Oh, there goes my teammate. No! Survive! Survive! Alright, let's try to get this dude. My bullets are really slow. That's the only problem right now for me. I'm not a good attacker. Oh, there he goes. Running into my boxes. I don't think I'm gonna get that kill. There's a giant triangle following me. There's a giant tank following me. Okay, let's. What happened to that dude that was about to kill? Oh, there's a free kill here. Very nice. Alright, I put my health to be upgraded. There is a giant wrench right down there, just shooting through the wall. Trying to get free kills. That's crazy. Alright, there is a giant tank again. Okay, there's a dude here, Taco. I remember seeing this dude before. I think I'm gonna go back to my original name, which is Banana Turd. So, oh, there's. Yeah, you missed. Dude tried to one-shot me. It's not happening, buddy. It's not happening, buddy. Let's try to attack this. There's a lot of people in this corner. There's a lot of people in this corner. Uh-oh. Alright, let's see if we can get a kill. Maybe this dude. He seems to be real. Dude, just stop it. They're trying to one-shot me. Stop it. Okay. No, I see that bullet. They are shooting at me with their little bullets, trying to kill me. It almost worked. Gonna get. Stop it. Stop. Oh my goodness, people. You gotta stop with that. Those bullets, bro. It's not gonna work. Alright. So. I don't know what to do here. We're kind of stuck. This is. I almost have max health upgrade. So let's see how that happens. I'm gonna try to get close to these people, and then my team will hopefully be able to get some of them with their amazing bullets. Alright, this is very nice. Look at this. We are getting closer to the other team. Probably gonna get some kills. There's a lot of bullets flying. Alright. I have max reload, I think. Uh-oh. We're getting shot. Alright, let's take the corner. Let's take the corner. The corner's pretty good. Let's take the corner. Let's hope our wrench teammate buddies can. There we go. Take the corner, my friends. Nope. Nuh-uh. Oh my gosh, they're respawning with the freaking. No. Oh, they killed our teammates. Killed our teammates. The fingers, dude. These people are savage with it. The savagery Oh, there. Okay. Okay. Please don't let him kill. Okay, there we go. Alright, we are back on track a little. We're back on track. Okay, so we're in the corner. Oh, look at. Oh my god, dude. There are people. We're getting one-shotted, dude. We're literally getting one-shotted. One tapped, brother. One tap. Stay behind the traps. Alright, stay behind the traps. Alright, there we go. Yeah. Alright, let's try to go down a little. Let's see if that can... we can do something. Let me follow the teammates. Oh my god, dude, they just run it. Alright, I don't think these dudes know how to play that well. They just run into the enemies. You're not gonna survive just by running into the enemies. Sorry to say. I'm sorry to say it. Alright, we got new people. We got this ghost guy, base ghost. Oh, there's people in here. Let's kill them for XP. Alright, shall we? Shall we do that? Yes, we shall. Alright. There, you see that? There's a dude in the corner. He's shooting through the wall. There's a guy shooting through the wall. That's how large he is. He reaches so far he can shoot through walls. My god, bro. Dude, they just spawn as the finger. And they try to get some kills. I kind of want to increase my bullet speed so I can get more kills, but you know how it is. More bullet speed means my traps that come out the back of my tank are probably gonna like hit a wall or something. Basically, high bullet speed is not good for close combat, and close combat is kind of what I want for this tank. So I don't even know if I want to upgrade the bullet speed at all, to be honest. Yeah, so that guy's shooting through the wall. That's not good. Let's see if we can go in there and kill these people. Maybe we can. I'm not too sure about this. All right, here. There's a dude over there waiting to shoot through the wall. I'm not gonna lie to you. He's probably just waiting to shoot us. All right, but well, let's see what happens here. I'm gonna stay pretty close. See if I can fight the tanks, the triangles. Oh, we are getting cornered actually. We are getting cornered actually. I think we're getting closer. I think we're fighting off the triangles. Alright, let's continue. Let's continue. I wish our friend up there, No Name YT, would help. I think he is helping. Alright, he's stopping the people on the outside from coming in. Alright, here we go. We are abandoning our post. I'm abandoning my post at least. Because I see there's people up here and it's kind of crazy. Gotta protect the teammates. Oh my god, nah, this is a bad situation. This is a bad situation. Let's see if we can stop the onslaught of bullets. Oh no, there. Okay, there goes our teammates. Can we save this one? Please don't die. Okay. Please don't die. Please, okay. I was the one to get one-shotted. I got a minute left on my gameplay. Oh my goodness. Alright, let's see. Where are we here? What should we pick? Should we... I kind of want to pick something like that, and then I'm gonna do some of that. Alright, let's do that. Okay, this dude is waiting for me to spawn, basically. So I'm not gonna spawn. Alright, let's get going. Let's see, I think there's... killed someone. Somehow. Okay, I have 0 movement speed. So I'm very slow. But I do have a little bit of upgrade in my bullet damage and whatnot. So I'm gonna see what happens. I'm gonna die right now, okay. God damn it. Okay, let's see. What else could... oh, Jesus. Guys, that was loud. Alright, let me just say that much. That was pretty loud. That was very loud, okay. So this right here, let's try this out. I'm actually gonna go to the bathroom real quick, cause I gotta piss. Alright, I'll be back. Alright, I'm back. And I brought a jacket because I was kinda cold. Ugh. Alright. Jesus, dude, I'm gonna put a different song just to just change things up. Alright. I know you guys want programming homework, but you know, I gotta do this. And yeah. Look, my next chapter is modeling computation. Right? Programming. Not really, but kind of. I think I want to read that, but okay. Bro, probability always confuses me, dude. Just confuses the freak out of me. Oh my god, okay. Alright, let's pick a song. Do you guys like Mr. Kendrick Lamar? Kendrick Lamar is pretty good. I'm gonna try that out. I like this song, this playlist. Mr. Morale. Alright, we got Mr. Morale. Alright, I might be going back to the notebook here because I think I need to do this by hand for me to learn this. Whatever. So in the experiment of a 5-card hand is the following an outcome or an event. Who knows? Let's read what events and outcomes are. I remember reading about that. But yeah. So we have outcomes, experiments, events, and sample spaces. Okay, so an experiment is a procedure that results in one out of a number of possible outcomes. So a subset of the sample space is called an event, and all of that possible outcomes is called the sample space. So an experiment is something you do to generate an outcome. The one of all possible outcomes, which is called the sample space, and we also call a number of outcomes, you can name them and call them an event. Okay, so interesting. So let's see. So if we have a red and blue die, the experiment is the process of throwing the dice. An outcome would be the blue dice has a number and the red dice has a number, and that is one outcome. The sample space, let's calculate the sample space. Why not? Let's try that out. That would be something. So we have blue 1 through, what is it, 6? Okay, and then we have that combined with red 1 through 6. So that's just 6 times 6, 36 is the entire, is the size of the sample space. That is that, right? Okay, that's what I did. So the sample space is this. Very nice. So an event is a subset of S. And they also said something. Yeah. So yeah. Okay. So an event is a subset of the sample space. For example, the event E that the sum of the dice is exactly 8 is the following set. You just get all the possible outcomes in the sample space that the numbers add up to 8. Okay. Oh, and we can... I remember doing that. How to count that. I remember. You get 2 categories. You do the code word thing. And then you could figure that out. Okay. I see there. Okay. So, playing cards. Alright. So a standard deck of cards consists of 52 cards. Each card has a rank and a suit. Okay, so deck of cards. Okay. This is what I don't want to memorize, bruh. Oh my god. So you have 2 through 10 ranks. These are the ranks. So 2 through 10, and then 4 lettered ranks. Okay, and then the suits is 4 of these things: spades, clubs, hearts, and diamonds. So the 8 of hearts would be an 8 and a heart. So it's 4 times 13, right? Yeah. Okay. Okay. So the sample space consists of the set of all. So the sample space of 5 card hands consists of the set of all 5 subsets. So that would be 52. Choose 5, which is pretty large, kind of. Okay, and the order in which the cards are dealt is not important. Okay, so for example, one possible outcome is this: so 2 hearts, 2 diamonds, 8 spades. What is that? Yeah, jack, club, and ace club. The number of different outcomes is your number of 5 subsets. Yeah, the event E jack, that the hand has 4 jacks, is that. So it has jack thingies, all the different jacks, which there's only 4 of. And then the last 5th card can be any of the 48 cards. So the number of outcomes any jack is 48. Right. Okay. Pretty straightforward. So discrete probability is the sample space is finite or countably infinite. Yeah, okay, discrete probability. And then we have almost all of the experiments analyzing the material of finite sample spaces. A set is countably infinite if there's a one-to-one correspondence between the elements of the set and the integers. An infinite set that is not countably infinite is uncountably infinite. Okay, so I don't really want to read that, but whatever. So examples of countably infinite sets include the set of all binary strings of any length, the set of ordered pairs of integers, and the set of all rational numbers. The set of real numbers is an example of an uncountably infinite set. In fact, the set of real numbers in a finite interval is also uncountably infinite. An example of an experiment with an outcome that is not countably infinite is a dart thrown at a 1 meter square target. The point at which the dart lands on the target is the outcome of the experiment, and they could be real numbers which are not countably infinite. Okay. So in the experiment of a 5-card hand is the following: an outcome or an event. Is an outcome? Is an event? In the example of a red and blue dice that are thrown, define the event E to be the number on both dice are a multiple of 3. Okay, suppose a coin is flipped 3 times. The outcome of the experiment is the sequence of outcomes. So it would be 3 tails or heads. Okay, how many distinct outcomes are there? Alrighty. I don't know. What is this? Something. This is definitely something, alright? This is definitely something. This is the subset. 3. Subset 3? No, hell no. That's not right. What? What the skib? How do you calculate this again? Isn't it just 2 to 3? Right? 2 to 3? Is it? Yeah. Okay. Alright, in the experiment where the coin is flipped 3 times, which set corresponds to the event that at least 2 of the 3 flips come up heads? Okay. At least 2 of the 3 flips come up heads. So there has to be 2 heads, at least. Probably that one, right? Because this one has only 1 head. And that's not... Yeah. How do you measure that one? I don't want to measure it. I really don't. I really don't want to measure it. Okay, a natural question to ask is, what is the likelihood that a particular outcome occurs? Or an event occurs, I'm guessing. A probability distribution over the outcomes of an experiment with a countable sample space is a function p from s to the set of real numbers in the interval from 0 to 1. Okay. So you sum all the probabilities of the outcomes and they have to equal to 1. Okay. So that is a probability distribution. And it says the probability of the outcome S is P of S probability. If event is if this thing is in the sample space is an event, then the probability of an event is literally the probability of all the outcomes in the event added up. Okay, that's cool. So, okay, let's see. So a dishonest dice player shows up to a game with a loaded die. The player's die is biased so that the outcome of a 6 is twice as likely to occur as the other numbers. Define an experiment that is a roll of the single die. The sample space is 1, 2, 3, 4, 5, 6. And the probability distribution over the outcomes is defined by this thing that they play here. Okay, so the event that the die comes up an even number is that the probability of the event is you add them all up. Right, that makes sense. Okay. So in the loaded die example, what is the probability that the number is a 5 or a 6? 5 or 6, huh? We do 1 over 7 plus 2 over 7, 3 over 7. I didn't need a calculator for that one, but I used it anyways. Alright. In many scenarios, the probability of every outcome in the sample space is the same. The probability distribution in which every outcome has the same probability is called the uniform distribution. Since there are sample space numbered outcomes in the sample space and their probability sum to 1, okay, for each outcome in a sample space, the probability is equal to 1 over the thing sample space. The uniform distribution reduces questions about probabilities to questions about counting, because for every event E, you have that it is then just the size of E over the size of the sample space in the uniform distribution. So return to the experiment with the red and blue die. If the dice are fair, then each of the 36 outcomes is equally likely. Okay, and then the event that the sum of the two numbers is 8 is the set this thing, right? 1, 2, 3, 4, 5. You know what, let me calculate that. I'm just about to calculate that. Okay, so we have 8 zeros. 1, 1. Right? 9 total. Okay. Right? Isn't that what that is? What if I do 9 choose 1? That's 9. 9. This is 5. Interesting. Interesting. The event that the sum of the two numbers is 8. Jeez. So what is this? Like something else? What the hell? What the hell? Oh, but it could only be a certain number. It can't just be 8 and 0 or whatever. Alright, so you know what? Nah. Alright, whatever. So return to the experiment with the red and blue die. If the dice are fair, this, yeah. Dude, does this look a little blurry? Looks a little blurry to me, but whatever. So return to experiment. If the dice are fair, yeah. So the event. So an experiment consists of 3 consecutive flips. So the outcome is basically a string of heads and tails, 3 heads and tails. Yeah, there are 8 possible outcomes, which are listed below. If the coin is fair, then all 8 outcomes are likely. Equally likely, the event that all 3 flips come out the same as these 2. So the probability that all 3 flips come out the same is the size of the event over the size of the sample space. But you could also say 1 over 8 plus 1 over 8 as well, I guess, which is 2 over 8. Okay, so in an experiment consisting of 3 flips of a fair coin, what is the probability that the first 2 flips are both heads? 2 over 8? Nope. Okay. Oh, it's 1 over 4. It is 2 over 8, but yeah. Okay, so in an experiment consisting of 3 flips of a fair coin, what is the probability that the first 2 flips are the same? So it could be heads, heads, 2 things, or tails, tails, 2 things. So it's 4 over 8, right? Half. So in an experiment consisting of a roll of a red die and a blue die, what is the probability that the red die is 1 more than the blue die? So yeah, we got 36 options. 36 options, 2 dies, 6 times 6. What is the probability that the red die is 1 more than the blue die? Let's just write them down. Let's write them all down. So we get 1, 2. Basically just 1 up to 5. So I think it's just 5 options there, yeah. Okay. So 2 dice are rolled. So, okay. Enter the size of this corresponds to the event that both dice are even. So how many outcomes are there where the 2 dice return are even? Where they're both even? Yeah. 2, 4, 6. That's just 3, right? Nope, okay. Oh, they can, okay, they don't have to be the same even number. They, okay. Of course. Of course! Okay, the same number. Into the size of the set corresponds to the event that both dice are the same number. Are the same number. 1, 1, 2, 2, 3, 3. And it goes up to 6, right? So, yeah. Into the size of the sample space. 1, 2, 8-sided dice are rolled. Okay. Eight times 8. Yeah. 2 6-sided die are rolled into the probability the sum of dice is 9. So, okay. So how many outcomes are have the sum being 9? It's a 6-sided die. So we can have 6 plus something. 3. 6 and 3. Right? We get 5. It's just 4. I think it's literally 4. Okay, so it's 4 times 1 over 6. 2 over 3. Not okay. What? Oh, it's 1 over 4 times 1 over 36. Whoops. Whoopsies, man. Bro, I just keep on. That's okay. So 2 6-sided dice are rolled. The sample space is 36. And they're asking me for the probability That's the event that the sum of the dice is 9. That is the sum of all the outcomes in the event. Each outcome has a probability of 1 over 36. So you just do the amount of the size of the event times 1 over 36. Okay, that makes sense. Okay. So a fair coin is flipped 3 times. Okay. Enter the probability that the 2 flips come up tails. That 2 flips comes up tails and 1 comes up heads. Okay. So the sample space is 2 to the 3 sample space. Each probability is 1 over 8. Okay, we have to do the number of the event times the probability of each outcome of the event, which is 1 over 8. So we do 1 over 8 times how many outcomes are in the event, and that's 2 flips are tails and 1 is heads. Okay, so 3 factorial over 2 factorial, 1 factorial. I don't know if that's right. It is right. That is actually right. My goodness. I did it using factorial, but yeah. Alright. Okay. Here we go with this thing. Dude, I've tried this question before. I have tried this question. Alright, I gotta do this question, bro. Okay, so files are stored on a distributed network. Multiple copies of each file are stored around the network, so that if one or more computers crash, the data is most likely to be available from at least one source. 3 copies of file are stored at different locations in a network of 30 computers, and that at a particular moment 5 random computers will fail. Okay, so each subset of 5 computers is equally likely to be the subset of computers that failed, whereas probably that there are no copies left. Okay. Meaning something. I already kind of know how to do this. I've seen it before, but oh my god. So there's 30 computers. Okay. Alright, so there's that. 30 computers. They're saying the event is that 5 computers fail, and it includes 3 specific computers that have a file on it. So how about this? We get 1, 2, 3, 4, 5, and these are the computers that we have chosen to fail, and we are gonna pick the 3 computers. So the size of the event is we pick 3 of the computers from the 30 that failed, and we're just gonna select them And this is a subset, I guess, so the order doesn't matter. So let's say file 1, file 2, file 3. And now we're gonna select the other computers. So we're just selecting 2. So we took out 3. So it's 30 minus 3. So from the 27, we're picking 2. So that's the size of the event space. Okay. And the probability of this happening, the sample space. This is the how many things are in the event. I can multiply this by 1 over the sample space to get the probability of each thing happening. So 1 over the sample space. So what the sample space? So this is an event, which I don't know, bro. I mean, I know it's 30. Choose 5. So 27, choose 2 over 30, choose 5. Yeah, I know that, but what the heck, dude? No copies left. I have to build this properly. So like there's a sample space. Sample space is the 5 filled computers. And then these are the computers that have the file. And but the sample space could be any of them. Yeah, okay. Okay. Okay, so yeah, so 30, choose 5. It's a sample space. Makes sense. And the probability of the event happening is 27, choose 2, divided by the sample space. Okay. Cool. That is something I know now. So messages are routed in a grid network. Every vertex in the graph is a computer that routes messages through the network. To better understand traffic congestion, consider only the traffic generated by messages going from point A to B. One reason to calculate congestion will be to put more powerful routers at network vertices that must handle more traffic. Thus, the goal is to determine the probability that a randomly chosen path from A to B goes through the vertex marked X. Consider only the paths that go directly from A to B. By a series of transitions, the path never moves downward or to the left. So we're trying to get all the paths that lead through X. So the event. So what are we trying to find? The probability that it goes through X. So, and it only goes up and right. I'm familiar with this question too, but let me do it anyways because I need to do this. So, okay. So the sample space is, I don't know, a subset. It's probably is a set with a number of things. So 1, 2, 3, 4, 5, 6, 7, 8. Ooh, wait, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. So 11 things. 1, 2, 6, 7, 8, 9, 10, 11. So it's going to be 11 ups or rights. 11 ups or rights. That would be so that would be 11 factorial. Nope, it's not 11 factorial. This is so it's wait. So what? So we gotta choose 11. The sample space is 11. So we have to choose. They have to add up or something. So like the rights have to add up to 1, 2, 3, 4, 5, 6, 7. We have to choose 7 rights and 4 ups. So 7 rights and 4 ups. And then we're just like moving them around. So that would be 11 factorial over 7 factorial, 4 times 4 factorial. That's the sample space, I guess. But they're asking about an event, specifically the outcomes that go through this X. So, yeah. So I would split that into 2 things. So I would say the outcomes that go to the X here, and then and then after that they go from X to B. So from A to X and then X to B. So from A to X, we got 1, 2, 3, 4 rights. Alright, so we got 4 rights, 2 ups. And that's 6 total, and then the other thing is 2 rights, 2 ups. Okay. So the 4 factorial kind of cancels, and then we get 6 factorial over 2 factorial, 2 factorial, 2 factorial. Interesting. So that's the event thing. Okay. So that's kind of weird. 6. Whatever, I don't know. But anyways, it says it's each equally likely, right? Yeah, it's randomly chosen. So I could just do E over sample space. So this E6 factorial. So that's E, and then the sample space is this thing. We got 3 over 11 is our No. No. They got 5 over 11. I got 3 over 11. I got this. Come on. I did the same thing. 1, 2, 3. 1, 2. Oh, wait. 3, 1, 2. Oh, I thought the X was here. Whoops. 1, 2, 3, 1, 2. Simple mistake. Alright, simple, bruh. Whatever, bro. I did it. I flipping did the same calculation. I just counted this wrong. My god. Alright. So this is correct. Whatever I did was correct. I just need to pay attention to like where the X actually is. Okay. They're saying there's a probability here. Alright. So okay. So a dealer deals a 5-card hand. 52, choose 5 is the sample space. The deck is perfectly shuffled, so each card is equally likely. So then, yeah. The distribution over the sample space is uniform. What is the probability that the hand has 2 pairs? The hand has 2 pairs. 2 pairs. Oh my god. The definition of having 2 pairs is that there are 2 pairs of cards. Each pair is the same rank. Okay. Okay, so they're saying what is the probability that the hand has 2 pairs? So let's see. So so what we're gonna do is calculate the event. The sample space is 52, choose 5. Alright, choose 5 cards. Okay, and then the event. Alright, the event is that you choose 2 cards of the same rank, which there are 13 of. So you choose one. So there's 13. 13 ranks, 4 of the same thing. What? So you do 13. The heck? So what do? We gotta choose. There's 13 ranks. We choose one. So that's what we do. So the first card has 13. What is this? So the first card has 52 possibilities because you choose any of them. And then the second card, let's just say, has to be, since the order doesn't matter, the second card has to be within the same rank. So we chose one card of one rank. So now there's 3 options left. Alright. So we just picked 2 cards out. So now there's 50 cards left. So we do oh wait. Wait, hold up. Hold the phone. 52 cards, we can choose any of them. And then the next one has to be of the same rank. So there's only 3 left within the same rank. And then the second pair, there are 50 cards left. but also we cannot choose from the previous like the previous rank, like the same pair we can't, like of the previous rank we can't choose that. And there's 2 in there that we can't choose from. So we have 50 cards and we can't choose 2 of them, so that's 48. Okay, so there's 48, and there's 3 other options for that. Okay, so we just chose 4 of them. And now the last card cannot be of the rank of the previous 2 pairs. So, what is that? We picked... There's 2 ranks that we cannot use. So it's 2 times 4, right? 2 times 4. So 52 minus 2 times 4 is 44. So yeah, we can do that. 52 minus 4, right? 48. Cool. So I got 42 times 3 times 48 times 3 times 44. Interesting.
Kendrick made you think about it, but he is not your savior.
Alright, let's see. Let's divide that by 52. Choose 5. And we got a different answer. So yeah, dang it, bro. Yeah, dang it. I tried to do it manually for some reason without using freaking discrete math, but I should probably do that. Alright, let's do it again, but try to use discrete math this time. So we're gonna choose 5 cards. We are choosing 2 from the same rank. So what is that? Choose. What is that? So there's 13. 52 cards, 4 of each rank. So here's what we do. Let's pick a rank. How about that? There's 13 ranks. We're picking one of them. Alright. And then we're going to pick 2 cards from that rank. So there's 4, choose 2. Alright, now there's 12 ranks. So 12, choose 1. And then we're picking 2. And now there's those are the 4 cards, and now we got the last card, which is how many cards are left, I guess. Well, what is it? We gotta choose it from a different rank. So get the last rank, 11, choose 1, pick a rank. And I think that's it. I think that's it. Do I gotta do something else? I don't know, but alright, let's try that. So 13, choose 1, 4, choose 2, 12, choose 1, 4, choose 2, and just 11. Okay, and then I got 52, choose 5. 0.023. Okay, almost got that right. What? I knew I had to add something. I can't just choose the rank. I gotta choose a card from the rank. So it's 4 times 4 on the top. You know, throw in a 4. Throw in a 4. Oh, never mind. That came out kind of weird. What the heck? 13, choose 2. What is this, bro? Select 2. What are they doing? They're doing 13, choose 2. So you select 2 ranks. And then you do... What? 13, choose 2? So I did 13, choose 1. Why is that the difference? Oh my god. So what is so we got 13, choose 2, which is 78. But what about 13 times 12? Yeah, that's not right. That's what I did. This is kind of weird. This is why I don't freaking discrete math kind of, bro. Like what? I'm not using the freaking. I gotta use the methods, bro. I'm not using the methods that I learned. I need to have faith in the methods. Okay. I don't know, brother. So I'm choosing excuse me, 5 cards. This card. Nah, I don't get it. I actually don't get it. I don't get it. Because, dude, what is the difference? Are you serious? Oh my goodness. Probably because there's intersections that I'm not thinking about. Oh. Oh, I think I get it now. Cause I did 13, choose 1 times 12, choose 1. And that's sort of like saying you had 2 different set of ranks. But I'm selecting from the same set of ranks, 2 of them, 2 different ones. So I would just put 13, choose 2. Instead of, because if I did 13, choose 1, that's like saying from my first set of ranks that has 13, I choose 1 of them. And from my second set, completely different set of ranks, that has 12, I choose 1 of them. But that is not the case. There is one set of ranks that has 13 ranks in them, and I'm just getting two different ranks from the same set. Nice. Okay, and I did this correctly though. Within the rank, there is 4. What's it called? Whatever. There's four different what are these thingies? Flavors. There's 4 different flavors to each rank, and I'm choosing 2 of them, 2 different ones. And the last one, I don't know. I kind of did that correctly, I guess. No, this doesn't make sense, dude. Okay, how about this? Cause they got 44. What if I did 13? So I'm gonna write down their thingy. Their thingy here. And I'm gonna put that into X variable on my calculator. So what if instead of putting 44, because that just seems kind of weird, what if I did 13 choose 3, 3 ranks, and I did 4 choose 2, 4 choose 2, 4 choose 1. So the last one would just be from the last rank. Choose one. A different rank. So what if I did that? Instead of 4 choose 2, it's 4 choose 1. Crazy. Alright. Yeah, I get a different number. Get a different number. This is just... What is the difference? Are you serious? Because, bro, what? I don't get it. I really, really don't get it. So somehow these have to be paired up together. Let me see the freaking... What? Select the ranks for the 2 pairs. Yeah, so we select two ranks. Select the suits for 1 pair. Select the suits for the other pair. What? Okay, and then what about the last one? So I guess it has to do with the number of cards you do, because like I guess they're building it up. They're saying there's 2 cards for this one. This pair. There's 2 cards for this pair. And we're building them. So you do 13 choose 2. And you just say, oh yes, it's a bijection. It bijects to the 2 cards. But this one only has 1 card, so probably you can't say it bijects from the 13 choose 2. You can't just biject a rank from that same combination. I'm guessing. So you can easily get these 2, but this last one, you can't reuse this logic for it. Okay. And this so this last one they're saying any card whose rank is not the same as the pairs, and we got 2 ranks taken off. Each rank has 4 cards. So yeah, the total number of cards minus the ones you already cannot pick anymore. What? I was not familiar with this. Even though I should have been. Guys, I feel freaking slow, bro. Just going through this. Like, bro, how long have I been doing this? Because I thought I could just select like each card or something. It would be simple as that. I'm missing some information in my brain. Alright. Oh my god. I have to do that. I have to memorize that. Like bijections, dude. Like bijections. What? Okay. Bijections, bro. So I'm gonna say like there. So if I had, okay. How do they even know to come up with this, dude? That's kind of weird. So you're building it. So there's pairs. And like this pair has the same rank. For some reason, bro, you just say bijection. They have the same rank here. Bijection, they have the same rank here. So you treat these two ranks to be the same. So like rank 1, rank 2. Alright, so you do 13, choose 2. They go into there. Okay, and then you need a rank in a suit. So individually you need mother freaking for rank for suit, choose 2. Also for suit, choose 2 for the other one. And the last one, I thought you could just do mother freaking, or what? Why can't I just do 13 thingy? What the heck? Is 44 divisible by 13? Is 44 divisible by 12? Oh my god, bro. Oh, it's divisible by 11, duh, yeah. The last one is... yeah, so this is the rank 3. Okay, so this is suit 1, suit 2, suit 3, suit 4, suit 5. So the third rank is going to be 11, choose 1. And then the last suit is 4, choose 1, which is 44. That actually makes sense, not gonna lie. That actually makes sense. So if I can give names to these sequences, that kind of makes sense. Yeah, because if I chose the ranks differently, like this is a subset, so I would have to, I need to build this in a way that accounts for like redundancy. So like the first two pair has the same rank, so I shouldn't give them two different ranks. Okay, so I gotta give them like a letter or something. Alright, I think I get it now. I think I get it. That was a little weird, but alright, let's type it into the calculator just so we have a sanity check. Alright, so 13 choose 2 times 11 for the ranks. Okay, times 4 choose 2 times 4 choose 2 times 4. Yeah, I got the same thing. Okay, I like this better. Okay, so it's kind of like programming. Like you have a sequence. Here I have the ranks, assign them to the pairs, and I choose them from the ranks that I currently have. And then you have the suits for that rank. Alright. Cool. Cool. So that's like bijection. Okay. Very, very nice. Oh my goodness gracious.
I'm proud of you. You broke a generational.
Alright guys, here's the deal. It's getting pretty late. Alright. This video is getting kind of long. I know it's not gonna get watched to the end anyways, but I like recording, but whatever. So yeah, I'm just gonna call it. I'm gonna call it here. My goodness gracious, dude. This is a long freaking video. Alright. So yeah. Um, uh, Suggest if you guys want to hear any music on Spotify or whatever. Uh, I don't care if it's copyrighted, dude. I'll still play it because I don't care, bro. I don't care unless they tell me. I'm just gonna use it and try it out, and if YouTube says something, I'll just like mute that part or something. I don't know. It doesn't matter. But yeah, bro. Yeah, suggest if you guys want any music or anything or any suggestions, put them in the comments. I have seen the comments about the programming homework. All right, I know you guys probably want to see that programming homework, but I'm not there yet. All right, I'm not there yet. I'm doing discrete math right now, so I'm just making this video. Why not? The programming will come though eventually. I have a few programming classes coming up, and I guess I'm planning on when I'm done with this class, I'm thinking of like I don't know, bro. I don't know. Maybe just make a miscellaneous video. It could be programming. Something that's not classwork, but it could still be programming. Maybe I'll show you guys me building a full stack thing, maybe like I follow a lesson or something, a guide of some sort, and then I'll like try to make a full stack application or something like that, and then I'll try to like post it on my website. But yeah, bro. Yeah, that's it. That's what's happening. This class ends. I have to finish it before the end of the month, I think. So, whatever. That's alright. I just have to do probabilities. And then I'll be done with this class finally. It's taken a while actually. But yeah, bro. Yeah, that's it. So yeah, I'll see you guys later. Thank you for watching if you did. Yeah, I'll see you later.